Hello everyone. The title of this tutorial is Understanding Simultaneous Linear Equations, or otherwise System of Linear Equations. If you want to understand simultaneous linear equations, you have to understand a linear equation itself. What is a linear equation? I think to understand linear equation, let us start with something very simple, a numerical expression. Don't forget to like, comment, and subscribe. Let's get started. Let's assume I have 6 plus 4, which is equal to 10, no doubt about it. So the question is, what if I replace this 6 with a box? This box contains a number, right? A missing number, which when you add it to 4, you get 10. And that number must be 6. At elementary level, this is what we call an open sentence. As you go higher, you start to replace numbers with variables. And what are variables? Variables are just letters, alphabets, right? A, B, C, D to Z. So I would like to replace this box because we are at higher level. Replace it with X, Y, or Z. So let me use X. This is an example of a linear equation containing one unknown variable. And why is it an equation? Because it contains an equality sign, right? And why is it linear? Because our unknown variable has a degree 1. You know, naturally it has a power of 1. Once the power is not 1, any number greater than 1, for example 2, once it is 2, we say it is a quadratic equation. But whenever you have an equation in which the unknown variable has a power of 1, that is the highest you can see in that equation, then we say that that equation is a linear equation. So this equation contains one unknown variable. A linear equation may contain more than one unknown variable. For example, you may have x plus y equal to 10. You may have x plus y minus z equal to 15. This is just an example. This contains 3 unknown variables. They are representing something. This is why I said subsequently we are going to talk about the real-life application of simultaneous linear equations. So, in simultaneous linear equations, a linear equation must contain more than one unknown variable. So what if I decide to remove this and replace it with y? Y is also to the first degree. It has a power of 1. Therefore, this equation remains a linear equation. But this time around, remember we started with x equal to 6, right? And the number here was 4. So let me just write it. 6 plus 4 equals 10. We have no problem with this. We have no problem with this. But is 6 and 4 the only solution to this problem? No. It is only when a linear equation contains one unknown variable that you will determine a single solution. But once that linear equation contains more than one unknown variable, you have to get infinitely many solutions, unless otherwise you have more than one linear equation, and that's where we are coming from. We want to talk about system. The moment you have this and another one, then you have a system. So let's see how this works. How many combinations of x and y do we have that can give us 10? Infinitely many. For example, I think I can say that 20 minus 10 is also 10. When x is 20 and y is minus 10, then the result will be 10 again. When x is 7 and y is 3, we're still going to get 10. I told you we have infinitely many of these combinations. So whenever they ask you to solve this, the answer to the solution is just what? Infinitely many solutions. But let me introduce another one. For instance, I have x minus y this time around. And we realize this is equal to 2. This is another linear equation containing 2 unknown variables. We have infinitely many combinations that can satisfy this equation as well. So let's try. I know if I have 7 here for x and y equals maybe 5, this will still be equal to 2. Yes. And maybe we have 10 and this is 8. This will be equal to 2. So we have infinitely many combinations. But the question is, do we have a combination that will satisfy the two equations? If there is, then that's where we are coming from. That's our main objective. We would like to determine that value of x and y that will satisfy these two equations simultaneously. This is why we have that simultaneous linear equation. We may have simultaneous quadratic equations, but we are talking about linear equations. So I know that 6 minus 4 is equal to 2. This means that x is equal to 6, y equal to 4. X equal to 6, y equal to 4. But remember, initially, when x is 6, y equal to 4, it satisfies the first equation. This is equation number 2. So it means that the solution to these two equations simultaneously are what? 6 and 4, respectively. When x is 6, y equal to 4, it will satisfy these two equations simultaneously. But once you are given only one, you will have infinitely many combinations. In such case, you say what? The solution to the problem is what? Infinitely many solutions, or infinite solutions. So you should know that the moment you hear about simultaneous linear equations, you should know that we are talking about more than one linear equation, and it must contain more than one unknown variable. So let me give you another example. If to say we have 2 plus 5 plus 6, I know this will give us what? 13, right? This should be 13. I think it is very simple. If we remove 2, we replace it with a box. Because this and this will give us what? 11. And we know that it's only 11 plus 2 that will give us 13. The moment we remove another one, so let me make this one to be x, this to be y. There's a problem, because we are going to have an infinitely many solutions for this particular problem, because we have two unknown variables. We have 6 here. 6 plus what will give us 13? We know that 6 plus 7 will give us 13. It means that x plus y must be 7. And there are a lot of different combinations of numbers that will give us 7. For example, 5 plus 2 is 7. 6 plus 1 is 7. Infinitely many. And there are instances where you have to remove this to replace it with z. You see that? So now this is another linear equation containing 3 unknown variables. The same thing we did earlier. This equation has infinitely many combinations that will satisfy this. But you may see another one like maybe x plus y minus z to be equal to maybe 8. It's just an instance. So in this situation, we have reduced the problem. Why? Because we can simply eliminate this. Once you add these two together, this will go, because z plus negative z will give us 0, but we'll still have 2 other unknown variables to solve. So we may have, again, in the third equation, you may have only 2 unknown variables like x minus y may be equal to 5. So in this situation, we have 3 equations to solve simultaneously, which in the end, we have to get a unique value for x, y, and z that will satisfy these 3 equations simultaneously. So this is just an introduction to simultaneous linear equations. In our next tutorial, it will be based on what? Real-life application of this system of linear equations. Thank you for watching. Do share to your learning colleagues. And don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.